This is the 14th video in the beginning programming series about Octagon, and this is part 2 of the Making Decisions video. And in this video we're going to look at combining more than one test into a decision. For more information, visit jb.works and at the search prompt type the TMT code shown at the bottom of the screen. In the previous video, we looked at situations in which we were making a decision. In this particular case, we were deciding whether we were going to go for a swim or not. And we used an any statement with a test in it. And we only had one test. And in this case, it was a test of whether we wanted to go for a swim or not. So what we're going to do in this video is look at situations in which you have two or more tests inside the same any statement. So in our new scenario, we have an any statement, but we have two or more tests. So we have test 1 and test 2. If both tests are true, we will run true. But what the any means is that if any one of these tests is true, we will run the true statement, the true code. So for example, if test 1 is true and test 2 is false, we'll still run the true part. If test 2 is true and test 1 is false, we'll still run the true code. We would only run false if both of these were false at the same time. And the any means if any one test is true, then we will run the true case. So now let's look at the case where we have to make a decision and we need to use two tests. And in this case, Eva and Jack want to buy this game, which is really cool, and it costs $10. Now, the test is whether Jack or Eva or both have the $10 to buy the game. So the first case is if Jack and Eva both have the $10, then fine, they can buy the game. Because the any statement is happy if any one of the tests passes, or if any one of the tests is true. So if Jack has $10 and Eva doesn't, yep, we can still buy the game. If Jack has no money and Eva has $10, then yes, we can still buy the game, because we only need one of these tests to be true. And the test is whether one of us has money or not, specifically whether one of us has $10 or not. However, if neither Jack nor Eva have $10, then we can't buy the game because they're not, the test cases are both false, and so we cannot buy the game. So let's take a look at a program version of this scenario. Okay, so this is the program that we're going to use to see if we can afford to buy this game. So the first thing we do is we've got two variables up here. One is called Jack's money, which is currently 0 because Jack doesn't have any money. And then the other one is Eva's money, and Eva has $10. So we print the title, and then we print how much Jack has and how much Eva has. Then the next thing we're going to do is we need to check if we can buy the game, and we do that here. And what we're doing is we're running two tests. The first test is testing whether Jack's money is greater than or equal to $10, because we only need $10 to buy the game. And the second test is testing whether Eva's money is greater than or equal to $10. And because this is an any statement, if any one of these two tests is true, which basically means if either one of us, me or Eva, if we have money, we can buy the game. But if neither of us has any money, then we can't buy the game. So let's run it and see what happens. So in this case, Jack's money is 0, Eva's money is 10, so yes, we can buy the game. So now let's change it so that we both have money. And we'll run it. And sure enough, yep, both got $10 and we can both buy the game. So let's say that I've got money and Eva doesn't. So I'm going to run it again. And there. So Eva's money is 0, my money is 10, but we can still buy the game. Let's see if we can buy it if we both don't have any money. So run it. And no, we can't. So you can't buy the game because we don't have enough money. And that's where the false action is taken. So remember earlier on we were talking about actions. So these are the tests. It's where the decision's made. This is the true action, which is yay, yes, we can go and buy the game. And this is the false action where no, we can't buy the game. And you can have more than two tests in an any statement. You're basically limited by the length of the line. And that means that you can do lots of different combinations of things. So this is a good example of having multiple tests inside an any statement, and that is a more complex type of decision. For more information, visit jb.works.